Great. All right, welcome everyone. Thank you for joining today's webinar, Large Scale 3D Printing, Realizing the Value from Design to Production. I'm Abby Delaney and I'm the Marketing Manager for BigRep. For those of you new to BigRep, BigRep is a global leader in large scale 3D printing and is developing the world's largest serial production 3D printer. In today's webinar, we are going to explore the million-dollar question, why size matters in 3D printing and the value that it provides. I have with me today the president of BigRep America, Frank Marangels, who you see there on the screen as well, and he's going to answer that question for you and provide some insight into companies worldwide and how they are putting the power of large-scale 3D printing to use for them. Just a little housekeeping before I turn it over to Frank. If you have any questions during today's webinar, you can enter those into the control panel, the questions tab over there, and we will answer those during the Q&A session at the end of today's webinar. If we happen to run out of time, don't worry, we will follow up with your question directly with you one-on-one after the webinar today. And so without that, I will hand it over to Frank. Welcome, Frank.
Thanks, Abby, and welcome everybody. We appreciate you being here. Today we want to talk about large-scale 3D printing, that's what we do, and realizing the value from design to production. When we think about the needs of additive manufacturing, usually they exceed the standard 3D printers today. That's why we say at BigRep, go big or go home, or more specifically, go BigRep or go home. So today we want to talk about a few subjects. What is large-scale 3D printing? What is large-scale 3D printing in industry? The value that large-scale 3D printing brings to industry, and then some very specific great case studies that we have, and then we'll pull it all together with a summary. So first, this is our BigRep 1. It's a machine that has been our go-to for the last 4 years. It is a 1 meter cubed machine. It is the ultimate serial manufacturer of large-scale 3D printing. We have a small video that will run here to show what it's doing. It is really the ultimate of German engineering, 500 kilograms of mass production, printing a windmill here that utilizes almost all of our 1 meter cubed printing area. And without large-scale 3D printing, this part would never be able to be printed. This was a real customer part, and the ability to design this windmill and to print it in one piece allowed them to even exist. So large-scale 3D printing really is an enabler for a lot of different technologies. So questions to ask yourself about 3D printing: if size wasn't a limitation, would you be able to create better prototypes using 3D printing? And if you did want a full-scale replica of your part before going to production, how easy would it be to produce, and how much would it cost, and how long would it take? I mean, these are some of the challenges that customers ask themselves every day and decide to buy a large-scale 3D printing because of that. With large-scale 3D printing, you really get what you need. You don't limit yourself. And why does size matter? Well, the most obvious is you get a one-to-one scale prototype that allows designers to get much more valuable information. So you get a part that matches your end-use part from a prototype standpoint. So what does that mean? You get to test fit, you get to test flexibility, you get to test strength, and you'll see later on in the steel case study that we're going to go through, they had a heck of a time before they had a large-scale 3D printer with the ability to really come out with good prototypes. The one-to-one prototype allows you to really reduce time in your post-processing, increases accuracy, and increases strength compared to what it would take to make a part in many pieces and then glue them together, which is what a lot of people do today when they don't have a large-scale 3D printer. A large-scale 3D printer offers you new end-use part possibilities. real go-to-market parts that aren't possible with a smaller printer. That opens up markets. It's really interesting. We'll talk about a couple of those later on in the presentation. And then something that really should be obvious, but might not be with some people, that you're able to create in one print a short production run of smaller parts with a bigger bed size, with a large scale 3D printer. So that's all very interesting, and let's get into some applications. So there's 4 major applications for large scale 3D printing in industry. And the most obvious, and the one we talked about a little bit already, is prototyping and modeling. And that's obvious because you're able to really print the exact size, 1-to-1 scale model of the part that you want in the end use part. And here on the left, one of our customers, Vilray Bosch, printing a sink or a tub that they are able to model before they go to production and utilize BigRep prototyping for all of their sample parts. And on the right side, a bionic propeller, again, bigger than your average 3D printer size requirement, only able to be printed with a large scale 3D printing. Our customers that are using our printers for prototyping and modeling fit into aerospace, automotive, architecture, consumer goods, furniture. Generally, if you look around the world and you see something that's bigger than 12 inches square, they're a customer of ours using our printers for prototyping. And that's just about everybody. The second application for large-scale 3D printing in industry is for tooling, jigs, fixtures, and this is probably the largest growing area for BigRep and for large-scale 3D printing in general, because it adds so many benefits to the manufacturing floor. So what I mean by tooling and jigs, I mean on the manufacturing floor. And I put that into 3 different categories. One is speed of manufacturing. So if you're able to have a custom tool that can support your manufacturing process, you can make that part faster and improve the efficiency of your manufacturing process. The second is quality. So many additive parts are used for manufacturing quality. We have a little example of a car model here, but in real life, one of our customers is using more than 30 jigs to help the quality of the assembly of an automobile. And this is really improving the bottom line, because if they can improve quality, then they can improve the output of their end use and improve their bottom line and reduce their scrap. The third item from manufacturing tooling, jigs and fixtures, that often gets overlooked, and maybe it's the most important, is safety. So if you're able to create jigs and fixtures that protect the safety of the manufacturing operator, this could be worth millions of dollars and worth the safety of your employees. So it's really important, and once somebody in manufacturing gets their hands on a large-scale 3D printing, they often buy 2, 3, 4 more down the road. So you don't know what you're missing until you have it. And in this particular case, it really adds a lot of value to the manufacturing process. So if you're in that space, I would investigate it if you're not already doing so. Our customers that are using our printers in industry for jigs and fixtures are aerospace, automotive, but really it crosses the entire manufacturing spectrum. The third application in large-scale 3D printing in industry is for patterns and molds. And that's really when you're looking to make medium volume manufacturing of the same part, and you're creating some pattern. And large-scale 3D printing, it makes a very efficient and very accurate and high quality pattern for such applications. And the 2 that we're showing here, Tyne Bridge is a manufacture of custom propellers, and we actually have a case study about them further on in the presentation. And they're using our 3D printers to make patterns for sand casting, which then they will make these metal casts out of them. And the right side is Geiger, which is using patterns of our large-scale 3D printer to make concrete casts. And so they may pour several or even 10 or more concrete molds inside any one of our patterns, and the ability to do it with large-scale 3D printing versus their alternate technology really was a game changer for them. Then what we have here as a note, but we don't have an example of it, is carbon fiber production. So you're able to make a pattern for carbon fiber assembly, and again, use that to make very light carbon fiber parts in a very efficient way. Again, our customers that are using our large-scale printers in industry for patterns and molds cross the full gamut of industries, aerospace, automotive, you'll see casting in marines, but wind power, construction, architecture, and many more. It just really any industry that wants this customization can use a large-scale printer for this application. So the fourth application for large-scale 3D printing in industry is really maybe the biggest opportunity, which is short production runs. And this is really where you see the value of additive. And additive has been limited up till now by the size of the part. And again, the part that a customer wants is often bigger than your typical additive or 3D printing unit. And here are two examples that we have here. The one on the left is a headrest from a Deutsche Bahn train. If you don't know, Deutsche Bahn runs most of the train service in Germany, and they operate and maintain the trains. So they don't manufacture the train. So getting some of the specs of the parts is very difficult for them. Not only that, add to it that some of these train cars are 50 years old, and it becomes a real big problem. So they are on a mission to produce as many parts as possible with additive manufacturing. So really to do on-demand spare part replacement. And this particular part is a headrest printed on a BigRep printer that would go into a train car to replace a broken headrest. And on the other side is a customer of ours, Paravan, and they customize automobiles for disabled use. So each particular customer is a different need, has a different need, and is a different service. So therefore, the part created or parts created are different, but they are used to enable a disabled person to drive normally again. And we're very proud to be partnered with them in their cause, but also the parts that they use for end-use production. Our customers in this space cross many, many sectors. As we talked about, mobility, packaging, consumer goods, architecture, and one that's not in here, but it's really a nice one, is the end-use parts, the signs and exhibits and fairs. So the ability to make displays with large format 3D printing, of course, is obvious. So yeah, this is really biggest growth area in the future for large-scale 3D printing. So if I pull together all of those examples, those applications, and I tried to say, where does the value of the large-scale 3D printing fit? It really is into these three different categories. Speed, so accelerating the time to market and reduced product development time. Cost, so minimizing the cost at all stages of the product development and manufacturing. That includes a lot of tooling reduction costs, which affects time and a very heavy cost. And improving the quality. So the ability to deliver a really intricate design on demand at full specification really is worth a lot for product designers and opening up new applications for end use part, giving the customer more information to make better decisions. So when I pull all that together, I say that large scale 3D printing delivers a competitive edge in design and in manufacturing. Now, so we have three case studies for you here that I want to talk about, and we have many, many more on our website. So if you want to look at BigRep.com, you can find many more details about these three case studies and many more case studies and ebooks about how customers are using large-scale 3D printing. But this first one is Steelcase, founded in 1912, a very large global furniture company. Pretty much everybody's heard of Steelcase. In 2016, Steelcase purchased their first BigRep 1 for their Munich office, and it was so successful that they purchased another system for their US office. Their challenge was to produce full-size prototypes with quicker turnaround. And their traditional methodology was really costly and time-consuming and labor-intense and took really weeks to produce a sample part. Their alternative would be to make a reduced version of that part, which did not give them all the information that they were looking for. It really lacked in many specifications for them to make good design decisions before they went to hard tooling, which was very expensive and limiting as far as future development goes. So what they found when they implemented BigRep large-scale 3D printing was that they could produce their prototypes 90% faster. So a weight-bearing seat shell that took 4 days to print would take 2 months in their traditional method, actually saving 2 to 3 weeks of labor cost. So those are big numbers from the bottom line as far as cost savings, both time and in money. But maybe the biggest benefit to Steelcase was that they could make more iterations in the time it takes to develop the system. So they can make a better piece of furniture because of that. More iteration means more improvements, means getting a better part to market. Or the other side of that is making the iteration faster, which gets faster time to market, which it's always very hard to put a dollar sign on time to market. But if you could get to market 3 or 6 months earlier and beat your competition, sometimes that's worth millions. And that's the case here with Steelcase. So the second case study is Etihad Airways, which is part of the Etihad Aviation Group. They have a team of more than 3,000 professionals around the world. Etihad Engineering has taken the bold challenge of producing 50% of their plane interior with additive manufacturing by the year 2025. That is 7 years from now. That's a big challenge. One of their prohibiting factors in meeting this challenge is the ability to have EASA and FAA certified materials. So one thing that Etihad has done is partner with BigRep to broaden the spectrum of the AM suitable polymers that pass this certification test. The goal of this group is to develop and test new materials that can meet EASA and FAA criteria. Of course, the partnership focuses on the cabin interior for new Etihad aircraft. And if you look at this picture on the side here, you can see a lot of plastic parts that could really be printed with additive instead of manufactured in the traditional way. And on the next slide, we'll talk about the benefits that they get out of that. So the first thing is really speed, that they can get faster production of prototypes and end-use parts by printing them themselves under their own control, but also reducing the tooling requirement and the time it takes to get the tooling. So the tools are expensive. They're not used for that many iterations, and it keeps them from the ability to customize each plane or any plane as they see fit. With the benefit of additive is each piece or each plane can be different than the last plane or the last piece. And when you have a hard tool, you're pretty locked into that tool for that particular part. So that's great in the reducing of the tooling cost, but it's also more than that. The ability to bring the manufacturing in-house and to make it on demand also greatly reduces the cost. Increase the quality because they get more of what they want and more flexible production. The third case study we have here is TineBridge, which I mentioned earlier, which is Metal Casting Partners. They are a custom designer of propellers for tugs, luxury yachts, fishing trolls, and ferries. In 2017, TineBridge decided to change their pattern manufacturing and to go to large-scale 3D printing and purchase the BigRep 1. The BigRep 1 prints a typical 750 millimeter part in less than 2 days, so that's much quicker than they had before, but the benefits are a little bit different. So as I mentioned, the speed difference is 2 days versus 3 days, so 33% quicker. That's a nice savings. The labor savings is nice too, 90% reduction in pattern makers' costs, so 2 hours versus 20 hours. But the real benefit to TineBridge is that the pattern makers are artists, and their ability to train and maintain the pattern maker on their staff got more and more challenging. And the cost of those pattern makers and therefore the patterns that they make got more and more expensive. So there was a lot of pressure on the cost of their propellers, the cost of their patterns, to maybe shift their production offshore to lower cost locations. So the ability to switch from this artist pattern to a digital pattern, the ability to CAD design and large-scale 3D print the patterns allows them to reduce the risk of relying on pattern makers and greatly reduce the cost of their pattern and therefore their end propeller costs. So perhaps keeps the survival of their company and certainly the company as they know it today. Very interesting cost benefit for this company. So industrial use cases, summary, again, go into this 3 categories. Increased speed, reducing speed of lead times, production time, and go-to-market time. And a lot has to do with the reducing of tooling, but also reducing costs of materials and in-house and contract labor, as well as increasing the quality of the output. So when you're making a digital part, first you'll make it exactly as it was designed. So if you're doing something manually, you're not dealing with any of the imperfections of their manual design. But if you're doing with large scale, you're getting an exact one-to-one replica. So you're actually able to get very complex designs, one-to-one replicas of the digital data for end use and production. You're able to do it quickly so that you're able to get more iterations out and get better designs if you're doing prototyping, or getting to market faster, which is the key in any competitive environment, and altogether bringing more information for the business managers, for the decision makers to make smarter business decisions. So what is achieved from all of this is a competitive edge in both design and manufacturing using large-scale 3D printing. So if you will bear with me for 1 second, and I will take just a minute to talk a little bit about BigRep if you don't know who we are. So BigRep is a global large-scale additive manufacturing company, and we have offices headquartered in Berlin, but offices in New York and Boston and in Singapore. The company started in 2014 with the machine on the left, the BigRep 1, 1 meter cubed printing, the first serial large-scale 3D printer. We are currently in the 3rd generation of the BigRep 1, so it is just a workhorse in large-scale 3D printing. Good German engineering. And in 2016, we were honored with the German Design Award, competing with 3,400 applicants for this BigRep 1. So we're pretty proud of the product itself. And in 2017, we came out with the BigRep Studio. The little guy, we say it's 1 meter by a half a meter by a half a meter. So a nice rectangular shape for a lot of applications. There are a lot of places that can't fit a 1 meter cubed 500 kilogram system like the BigRep 1. So the BigRep Studio was a nice fit for that, but still had 1 meter by a half in build area, so quite a nice big area. And we're proud that this year the BigRep Studio won the German Innovation Award, so that's fantastic. And BigRep itself as a brand this year won the German Brand Award. So we're very proud and humbled and honored to have this recognition from these German agencies. And as I tell lots of people, there are a lot of great German designs, and if we can win these awards, we're very proud of that. We have a partnership with TNO, which is a research institute to help us come out with new systems and new technologies. You will see new technologies coming out with us very shortly. We have very interesting announcements coming at Formnext this year in November, so please stay tuned for that. And by the end of last year, we had more than 250 printers and far exceeded that by now. And last but not least, an amazing set of just great, very big, large companies that are invested in us, that believe in us, that include Kerber, Kluckner, Kohler, and most recently, the biggest material company in the world, BASF. So we're very proud to have them as partners and investors and be with us on this amazing route to success that we believe in BigRep. So that's it. I hope you enjoyed. I hope it was valuable for you. And now I'll turn it back to Abby to see if there was any questions.
All right, great. Frank, that was an amazing presentation, and so amazing to see all the cost savings, speed, and quality that these companies are able to achieve. And of course, we do have lots of questions that have come in that time you were presenting there. The first one comes from David, and he's wondering if there's customers out there that are using large-scale 3D printing like BigRep to make actual end-use parts.
Yeah, David, what I did mention a couple in the presentation, but one that was not in the presentation that we're most proud of is Boyce Technology in Brooklyn, New York, and Boyce makes a product that for the New York Transit Authority and for the trains. Up until recently, they've done their manufacturing with more than 35 5-axis CNC milling machines, and that's just the core of what brought them success. And if you asked them a year ago, they would say, I don't want additive, it doesn't help me in my production, blah, blah, blah. I visited them a few weeks ago, and the owner, Charles Boyce, said to me, I was wrong. I can't live without large-scale 3D printing. So it is a part of many pieces of everything that goes out the door now. So now there is a major piece that's going into all of the train stations in New York that includes, I think, a dozen BigRep end use parts. So we're pretty proud of that success. And more customers are integrating uh, additive parts from large scale 3D printing, because that's one-to-one scale and printing and gives you the quality that you need. So and actually I will say that Boyce was nice enough to do a case study with us, and you should be able to see that very shortly in the next couple of weeks. Case study from BigRep partnered with Boyce.
All right, great. And just once that's out, I will make sure that's available to all of you on the webinar as well. Okay, we got another question here. This one comes from Rick, and he wants to know the difference between the large-scale 3D printers that are out there, BigRep versus some of the competition. What makes BigRep stand out?
Well, thank you, Rick. I think it's an excellent question, one that I try to answer every day, because we are the premium product in the marketplace in large-scale 3D printing, and we need to justify that difference all the time. And one thing is the BigRep systems were designed for large-scale 3D printing, so you'll see that they are big, heavy, solid machines. Now, it's not just that they're big for the sake of being big, but when you are making large parts, you take what might be a small problem in a small printer, like bed leveling. Bed leveling in a 8x8-inch printer is a challenge sometimes, and you guys that use regular desktop printers, you know that sometimes if the bed's not level, you don't have parts that stick, and you don't have very good prints afterwards, or you print a lot of spaghetti. So now expand that to 1 meter square bed that you're trying to keep within a few tenths of millimeters. Now you challenge that by heating it up to 60 or 90 degrees C, and you expand, you have a lot of problems. So I'd say first it starts with good German engineering to design the machine for the application, which is making large scale prints. Some of my competition start with a small printer and just make a bigger bed and extend the carriage, and that just doesn't succeed. If I had more time, I would get into all the bits and the bytes, Abby, about why each feature of our machine is better, different than all the others. But generally, it's German engineering. I did have two other things in the decision, because the other one is cost. So this first is the engineering, but you need to think about cost and speed when you're talking about large. You want the ability and speed to print in several resolutions. So we have 0.6 millimeter, 1 millimeter, 2 millimeter resolutions. So sometimes you want the part faster, or sometimes you need to print it faster. Faster might even be a weak print, but if you didn't have the right resolution, maybe you wouldn't be able to print in the right amount of time. And the last thing is cost. When you're making a big part, you have to make sure that you have very fair material pricing structures so that your materials can be affordable to your customers. And yeah, so those are the three categories: the engineering, the speed, and the cost.
All right, great. And the next question kind of is a good follow-up to that one. It's what materials are people printing on large format, and what materials?
Yeah, so the materials are growing all the time, and we have our own engineered materials for the BigRep system, which really helps because we design it for large format, we design it for our machines, we design the software for those machines. Having said that, we also are open systems, so our customers can put anyone's material on our machines. Of course, then we are not responsible for the program that was run, but the software has the flexibility to create their own program for it. But we have materials that are PLA. We have a bio ABS, which is like ABS, but it's a biodegradable material, so it's better for the environment. And we have a partnership with BASF, not only just from an investment into BigRep, but also from a material development. So every day they're developing materials, they're developing it to work best on a BigRep printer.
All right, great. And we're just going to keep rolling here. The next one kind of feeds off that too. Is how do you get a strong part? Is it all in the materials? How does that work with an open frame printer like BigRep has?
Yeah, so it starts with the materials. So the materials have to be able to bond to the layer below and not warp in an open frame environment. And so we have engineering materials that promote isotropic strength between the layers and less likely to warp within a open frame environment. So if you design the materials for the application. Again, BigRep, I say again, I didn't say it in this presentation, but I say it every day. BigRep starts with applications, then designs materials for those applications, then only then systems to use those materials. And if you start that way rather than the other way around, starting with systems, then you have a structure that really works for the customer's benefit.
All right, great. And it looks like we've got time for just one more question. This one kind of goes into the value of 3D printing in general, but what's the best way to justify a printer? A lot of the people on this webinar, when they registered first time, how do they justify purchasing a printer?
Yeah, so I would take one application, keep it simple for your management, keep it simple. There are so many benefits. You don't know how many times, Abby, that customers said, I don't need it, I subcontract, I only use one part a month, and they buy their first machine, and 2 or 3 years later, they have a fleet of machines in a big room because everybody sees the benefit. So I would say if you're in prototyping, pick one product, maybe a big expensive product that has a big challenge in go to market, buy a machine. As soon as you bring it in, everyone else is coming up to you to say, oh, can I use it? Can I print another one? You'll run out of capacity by loaning the application. In manufacturing, which often doesn't even know about large scale 3D printing, all they need is to look at what it costs to make their tools, their jigs, their fixtures, how many safety issues, what if they had it in-house and can customize that. One other thing, if you're in manufacturing, you can create your entire line of jigs and fixtures before you even have a prototype. All you need is the CAD data, and you can make an entire line of fixtures and process equipment before you even have a prototype. So you can be ready as soon as the first prototype comes. So there are so many options. I would have to talk to anyone individually to say which one fits you. But generally, pick one, go to your management. If you don't have a large scale 3D printer in house, then you will probably buy 3 or 4 more in the next few years.
All right, great advice there. And we did have quite a few more questions, and I'm really sorry that we weren't able to get to those. But like I mentioned, we will follow up with those after today's webinar. Just one quick thing to remind everybody that we are online, so please follow us there. It is a great way to stay up to date with all the latest case studies, especially the new ones that Frank mentioned that we will be having coming out later this year as well. We post our blogs there as well as where we're going to be at around the world for various events too. And speaking of events, in case you are in Chicago next week, we will be at IMTS. We are in the West Hall, the third floor, booth 432005. I'll send a map out so that you don't get lost in the giant McCormick Center. And then also at Formnext, like Frank mentioned, that's where we'll unveil the latest printers that we have coming out for BigRep. And so before we wrap up, Frank, do you have any final tips, comments?
Yeah, just as I alluded to earlier, we just touched the surface here on some of the benefits and some of the applications. BigRep is excellent at creating case studies and ebooks. So if you want to learn more about where large-scale 3D printing fits into your space, go to www.bigrep.com, and you could spend days there learning about large-scale 3D printing.
All right, great. Well, with that, I would like to thank Frank again for joining us today, and you as well. Thanks for taking time out of your busy schedule. I'm sure we appreciate that you were here with us, and we hope to see you next time. Thanks, and have a great day.
Thank you, everyone.